Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the mysterious idea of parallel universes and what our own reality might be quietly revealing about them. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these gentle explorations comforting. And when you're ready, feel free to leave a comment telling me where in the world you're listening from and what time it is for you right now. It's always a small joy to see all the places we gather from, each of us in our own little slice of time. Now you can dim the lights, maybe turn on a fan for a soft background hum, and let your thoughts drift. Together, we'll begin our quiet walk into the idea that reality may be more expansive, more layered, and more softly mysterious than it first appears. And if your mind begins to wander at any point, that's perfectly fine. Let it drift. We'll still be here, unfolding the story gently. If you lie still for a moment and simply listen to the quiet around you, reality feels like something familiar. It's the room you're in, the softness of your blanket, the faint glow of a phone screen resting nearby. It's the steady rhythm of your breath, the sense that everything around you is stable, connected, and perhaps even obvious. Most of the time, reality appears as a single, solid thing, like a table made of wood, unmoving and trustworthy. But this simplicity is more like the surface of a pond at dawn, calm from a distance, yet full of invisible ripples, currents, and depths once you look closer. Our everyday senses give us only a narrow window into the world. They capture just enough to keep us safe, comfortable and oriented, but not nearly enough to reveal what reality truly is. We see only a tiny band of light, just the colours our eyes evolved to notice. We hear only a thin slice of the sounds that vibrate through the air. What we call here and now is already a softened version of something broader, filtered by biology and shaped by the mind's preference for simplicity. When you slow down, this filtering becomes more noticeable. You might recall how dreams can feel deeply convincing while you're inside them, how a memory can blur with time and become something both real and not real. Or how two people can remember the same moment completely differently. Even in daily life, reality reveals itself as a flexible thing, more like a story the mind keeps revising than a fixed photograph. These small cracks in the familiar picture remind us that what we see is not the entirety of what exists, merely the version of it that our minds find easy to manage. And once we acknowledge that the world might be deeper than it appears, a gentle question rises as naturally as breath. If what we perceive as only one layer, how many layers might there be? Science began asking this question long before the idea of parallel universes became popular in movies or novels. Physicists started to notice that the universe behaves in surprising, almost dreamlike ways when viewed up close, at the smallest scales. Tiny particles seem to hold many possibilities at once. Light behaves like a wave and a particle, depending on how we observe it. Even something as simple as measuring a particle can change its outcome, like gently touching a spinning top and altering its tilt without meaning to. And yet, despite these strange behaviours underneath, our everyday world appears stable. Walls do not shimmer, chairs do not fade in and out between possibilities. Reality feels settled. There is a curious tension between these two layers, the softness of the quantum world and the firmness of the world we walk through. It is in this tension that many scientists first began to wonder whether what we call the universe might just be one frame in a much larger film. Some theories suggest that what we experience daily is only a single thread in an enormous tapestry. Not the whole cloth, but one strand woven alongside countless others. Each strand may hold a slightly different version of events, or perhaps an entirely different structure of laws and possibilities. If this tapestry is truly vast or possibly endless, then our reality might not just be part of something big, it might be part of something unimaginably expansive. To imagine this gently, Picture a library that stretches so far that its shelves disappear into a soft horizon. Every book on every shelf tells a version of reality, some familiar, some strange, some almost like ours, but with one small difference. A decision changed, a star born earlier, a world without mountains, a universe where physics leans just slightly differently. You're holding one book from this library. It feels like the only story because you live inside its pages, but the library may still be there, quietly surrounding all of us. The idea of parallel universes is not just a science fiction curiosity, it's a response to patterns, puzzles, and small whispers hidden in the structure of the world. It's a way of saying reality might not be a single object, but something layered, a gentle cloud rather than a single stone, a mosaic rather than a single tile. This does not make our world any less meaningful. In fact, it often makes it more precious. Because even if there are countless realities, this is the one you're experiencing right now. This is the story unfolding beneath your fingertips, the one carried by your breath, your memories, and the quiet details of your life. And so, as we begin this journey tonight, we hold on to two things at once: the comfort of the world we know, and the curiosity that there may be far more beyond what we see. Like standing at the edge of a forest at dusk, familiar trees close by, and a vast, gentle mystery waiting in the distance. You don't need to grasp everything at once. You only need to walk slowly and let the ideas drift through you like a breeze. If you think about the world the way we usually do, it feels like a single story unfolding from one moment to the next. Morning becomes afternoon, afternoons fade into evening, and each day seems to follow the same rules with comforting reliability. But every now and then, something makes that simple picture wobble just slightly. Not enough to frighten us, only enough to remind us that the world might be more layered than we first assumed. These small tremors can feel like a breeze brushing past your thoughts, hinting that there is more behind the curtain than what your senses allow you to see. Sometimes this feeling arrives through experience, a moment of déjà vu so vivid that it feels as if you've stepped into a scene you already lived, a memory that shifts subtly every time you revisit it, or that strange sense right before sleep, where you're not sure if you're recalling something real or dreaming it in the moment. These tiny moments are not proof of anything unusual, but they quietly soften the boundary between what we call real and what we call imagined. They remind us that the mind is not a perfect camera capturing the world exactly as it is, but a storyteller weaving scenes from limited information. Science, too, has discovered cracks in the otherwise solid picture of reality. When physicists examine the universe at enormous scales or incredibly small ones, they find patterns, puzzles, and unanswered questions, little gaps in the puzzle that don't quite fit into the straightforward world we walk through. These gaps are not flaws, they're invitations. They tell us that the universe might not be a simple brick wall, but rather a vast tapestry woven with threads we've only begun to recognize. One such puzzle is the mystery of why the universe seems perfectly arranged to allow stars, planets, and life to exist. If some of the universe's numbers were even slightly different, numbers describing gravity, the mass of tiny particles, or how quickly space expands, then the universe we know would collapse into nothingness, or drift apart too quickly for anything meaningful to form. Scientists sometimes describe these numbers as finely tuned, as if they've been set with remarkable precision. Instead of presenting these values as mathematical symbols, imagine them as delicate knobs on a control board, each one needing to be in just the right position to create a world as gentle and complex as ours. No equations are necessary to feel the careful balance at play, a balance that raises deep questions about why everything aligns so well for life to appear. Another puzzle lies in the earliest light we can observe, a faint glow left behind from the universe's beginning, something like a cosmic photograph taken when everything was still unbearably hot and dense. From Earth, this ancient light spreads across the sky like a soft, uneven blanket. Scientists study it to understand how the universe grew and expanded, but they sometimes find oddities in the pattern, a slightly colder patch here, an unexpected alignment there. These anomalies could simply be quirks of nature, or they might hint at something beyond our universe brushing against it long ago. The idea is speculative, not proven, yet it is gentle enough to make one pause, as if our universe might not be entirely alone. Even time itself offers little hints that what we experience is only one version of a larger, more mysterious system. We feel time streaming forward, moment after moment, like stepping stones across a river. But the deep physics that describes time does not insist on a single direction. Instead, the laws underneath allow time to move much more freely than our senses do. It's as though time at its core is less like a straight arrow and more like a flexible thread drawn taut only where consciousness touches it. All these cracks, in perception, in physics, in the faint early light of the cosmos, do not break reality. They simply suggest that reality might not be a smooth, flat surface. It might be textured, it might be layered, it might hold gentler mysteries tucked inside its folds. When you zoom out further, the universe itself shows signs of being incomplete, or perhaps simply part of something larger. Space is expanding, not just at a steady pace, but accelerating, as though an unseen breath is pushing galaxies apart. If you imagine the universe as a softly rising loaf of bread, galaxies are the raisins drifting farther away from one another as the dough expands. This expansion brings up a quiet question. If the universe is stretching, what lies beyond its stretch? Is it stretching into something, or is something else expanding alongside it too far for us to see? We don't need to introduce numbers or equations to capture the wonder here. The universe is growing peacefully and steadily, and we, floating on one of its smaller islands of matter, feel only a faint trace of this motion, a reminder that the cosmos is more dynamic than our senses reveal. These mysteries don't demand that parallel universes must exist. They simply open a soft window to the possibility. They show that the universe we observe, the one containing your room, your breath, your memories, fits together in ways that suggest it might not be the entire story. Incomplete puzzles are not failures. They are invitations to wonder. As we continue moving deeper tonight, imagine that reality is a fabric woven with threads of many colours. What we see is just the topmost pattern, the one that appears neat and familiar. Beneath it may lie threads that twist, mirror, split, or stretch into places beyond our reach. And some of those threads might be pathways into entirely different realities, whether they branch quietly from quantum events or bloom far beyond what our telescopes can see. When you soften your attention and allow your imagination to breathe, the cracks in the illusion stop feeling like flaws. They become doorways, not to fear, but to curiosity, and the universe becomes once again something vast enough to hold not just one world, but perhaps many. When you think about choices in everyday life, they usually feel simple and singular. You either pick up a glass of water or you don't. You either send a message or leave it unsent. Each action seems to carve a single path forward, like walking along a narrow trail through a familiar forest. But in the deeper layers of the universe, layers far smaller and softer than anything we can see directly, nature behaves in a way that doesn't follow these neat lines. Instead of choosing one path, it sometimes holds many paths at once, like a melody that carries several notes together in a single breath. This idea is called superposition, but the word itself is not the important part. What matters is the image behind it, a gentle moment where possibilities rest together side by side without needing to collapse into just one. To imagine this, think of a coin spinning in the air. While it spins, it is not simply heads or tails, it is in a kind of in-between, a quiet overlap of both outcomes. Only when it lands does one result become clear. In the same way, particles in the quantum world do not choose ahead of time. Instead, they hover in a soft cloud of possibilities, each one as potential as the next. Except unlike the spinning coin, these quantum possibilities are not the result of motion or blur. They are genuine states, existing together, all at once. The universe at its smallest scales does not rush to make decisions. It waits, holding its breath, letting multiple versions of reality sit together in a delicate, shimmering harmony. When scientists describe these possibilities mathematically, they sometimes use symbols that look sharp or abstract. Greek letters, arrows, or combinations of numbers that appear unfamiliar. But the essential idea can be expressed gently, without symbols. Imagine a lantern that glows in several colours at once: soft gold, pale green, faint blue. You cannot say the lantern is only gold or only green. All the colours exist together, overlapping gently. A particle in superposition is like this lantern, not forced to pick only one colour until something touches it and interrupts the quiet balance. This soft coexistence is not limited to particles of light or tiny electrons. It is a property baked into the structure of reality itself, whispering that the universe is more fluid than we might assume. While our everyday world feels solid, chairs stay chairs, walls stay walls, the quantum foundation beneath everything behaves more like a gentle mist of possibilities. Not chaotic, not unstable, simply open, flexible, and patient. You may wonder why we don't see objects around us behaving this way, why your cup does not hover between being full and empty, or why your room does not flicker between a dozen shapes when you turn off the light. The reason is simple and soothing. Superpositions are delicate, like strands of silk caught in a breeze. The world around us is full of interactions. Air molecules brushing against surfaces, warmth drifting between objects, faint vibrations passing through the floor. These interactions disturb the fragile overlaps of possibility almost immediately, nudging the world back into a single, familiar form before we notice anything unusual. In the next session, we'll explore this quiet collapse more deeply. But for now, it's enough to know that superposition is not absent in our world. It is simply hidden beneath layers of gentle noise. Perhaps the most calming way to picture superposition is to think of choices in your own life. Before you choose, many possibilities exist in your mind at once, not yet contradictory, not yet forced apart. You could go for a walk or stay inside. You could speak or stay silent. You could continue listening or let your eyes grow heavy and drift towards sleep. Before the decision, these options rest softly together, a small human echo of the way the universe itself holds possibility. Some interpretations of quantum physics, such as the many worlds idea, take this picture further. They suggest that when a particle resolves its overlapping states, it doesn't simply discard the other possibilities. Instead, each possibility may continue on its own path in another branch of reality. One version where the particle lands here, and another where it lands there, both unfolding quietly in parallel. You can picture this as a tree in a peaceful meadow. Every time a choice or interaction occurs, the tree grows a new branch, not breaking the old ones, but expanding the canopy into a more intricate shape. Whether this branching truly forms separate universes is still a mystery. Scientists debate it, not with finality, but with curiosity. The important thing is that superposition opens the door to think about reality as something more expansive. It suggests that the universe may not be as committed to single outcomes as our everyday experience implies. Consider too how comforting this idea can be. Instead of a rigid world where things must choose instantly, superposition suggests a reality with softness built into its core. A reality where multiple futures can coexist, if only for a moment. a reality where the fundamental building blocks of existence are not hurried or narrow, but quietly abundant. Even the smallest example of superposition, a single particle hovering between here and there, invites a gentle sense of awe. It means the universe holds more space for potential than we often realize. And if the foundation of reality itself is made of a possibility, then the larger structures built upon it, stars, galaxies, perhaps even consciousness, may also carry this quiet openness in ways we have yet to fully understand. As you rest and listen, let this idea settle softly around you. The world is not limited to a single narrow path. Beneath its familiar surface lies a gentle shimmer of overlapping realities, each one a whisper of what might be. And whether or not those whispers form entire universes of their own, they remind us that existence is not as rigid as it seems. It is open, flexible, and full of potential, just like the small turning moments of your own life. If superposition is the universe's way of letting possibilities rest together, then entanglement is its way of letting two things remain connected even when they drift far apart. It is one of the most quietly astonishing features of the quantum world, a kind of hidden thread tying two particles together, so that whatever happens to one is immediately reflected in the other, no matter the distance between them. Even if one particle is here beside you, and the other is somewhere beyond the reach of any telescope, they still share a single, intertwined story. To understand entanglement without sharp symbols or complex equations, it helps to imagine something familiar. Picture two small lanterns lit from a single flame. Once separated, they seem like independent lights. One might be placed in your room, the other might be carried far across a quiet valley. But no matter how far apart they travel, the two lanterns carry the same original spark. In the quantum world, entangled particles behave similarly. They act as though they share a single flame of information, glowing in harmony across enormous distances. In classical physics, objects are separate. A pebble thrown into a river does not instantly affect a pebble in another country. Yet in the quantum world, particles that interacted in the past can become entangled, meaning they share properties in a way that defies the everyday logic of space. If one is measured to spin up, the other will show a spin that is perfectly correlated, even before you look. And though physicists sometimes write this using symbols or arrows, you can imagine it more softly, like two leaves drifting on separate streams, yet still moving in a rhythm that mirrors one another as though they were choreographed by an unseen hand. But entanglement is more than simple coordination. It suggests that the universe cares less about physical distance and more about the relationships between things. In our daily lives, distance is one of the clearest boundaries. If you move your hand, it does not cause a lamp across the room to flicker. But in the quantum world, a pair of entangled particles behaves as if space between them is almost irrelevant. If one particle is touched by an observation, the other responds instantly, without any signal passing through the space between them. This does not mean information travels faster than light, or that messages can be sent instantaneously. Instead, entanglement reveals something more subtle. The two particles are not truly separate to begin with. They are parts of a single, deeper structure that only appears divided when viewed from above. It's a little like reading two pages of a book and thinking they exist independently, when in reality they form a continuous story bound within the same cover. If this idea feels strange, that's because it truly is. Even Einstein struggled with it, famously calling entanglement spooky action at a distance, not to criticize it, but because it didn't fit into the neat geometry of classical space and time. Yet experiment after experiment has confirmed that the world really behaves this way. It is not an illusion or a philosophical trick. Entanglement is as real as the warmth of your blanket or the hum of a fan in the background. The most calming way to hold this idea is to imagine the universe as a great field of relationships, rather than a collection of isolated objects. everything that exists has a story, and sometimes those stories intertwine so deeply that separating them is impossible. Entanglement is one expression of this interconnectedness. It tells us that the universe is stitched together in ways far more intimate than our senses alone can reveal. You might wonder why we don't see entanglement at the scale of everyday objects, why your cup and your pillow don't behave like paired lanterns, dancing together in perfect synchrony. The reason lies in the same gentle process that hides superposition, interactions with the world around us. Entangled states are delicate, like thin frost patterns on a window. The slightest touch, a warm breath, a shifting breeze, dissolves them. In the same way, entanglement between large objects is washed away by countless interactions with air, light, and heat. The quantum threads are still there, but they spread and tangle with so many surrounding influences that the original pairing becomes impossible to see. Despite this, traces of entanglement ripple through the world at every moment. They guide how particles interact, how atoms form bonds, and how information flows at the deepest levels of reality. In fact, some physicists believe that entanglement may be the tapestry on which space-time itself is woven, that the very geometry of the universe may emerge from networks of interconnected quantum states. Whether this is true remains an open question, but it offers a gentle image. Space not as an empty stage, but as a web of relationships. When you reflect on this idea, it begins to feel less like a scientific oddity and more like a poetic truth. We too are shaped by connection. Our memories, our habits, our emotions, they all arise from the relationships we hold with others and with the world. In this way, entanglement echoes something deeply human, that separate things can still belong to a shared story. The possibility that entanglement could extend across vast distances invites wonder about what lies beyond the visible universe. If particles can remain linked across space, perhaps different regions of the cosmos share patterns we cannot yet detect. Perhaps the structure of the cosmos is not a scattering of isolated galaxies, but a vast interconnected fabric. And if the universe is connected so intimately within itself, it is not unreasonable to wonder whether connections could exist across boundaries we have not yet imagined, even across different universes should they exist. We do not need to claim that such connections are real. It is enough to rest in the curiosity they inspire. Entanglement whispers that separation is not the fundamental rule of existence. Connection is. And once you accept that, the idea of parallel universes becomes less like wild speculation and more like a natural extension of a universe where boundaries are softer and relationships are deeper than we once believed. As you listen in the quiet, let this image linger. Two distant lanterns glowing in harmony, lit from the same flame, sharing a story that distance cannot erase. In their soft light, the universe feels a little more mysterious, a little more connected, and perhaps a little more open to the possibility that many worlds may be intertwined in ways we're only beginning to understand. If superposition shows us that the universe can rest in multiple possibilities at once, and entanglement shows us that particles can share a single story across great distances, then decoherence is the gentle process that explains why we don't witness these strange behaviours in the world around us. It is the quiet boundary that keeps the quantum world tucked beneath the familiar, everyday reality we move through. Decoherence is not a collapse in the dramatic sense. Instead, it is more like a soft dissolving, a whisper of order blending into the surrounding noise until the delicate quantum possibilities fade into a single, ordinary outcome. To understand decoherence without using equations, imagine a droplet of ink falling into a still bowl of water. For a moment the ink holds its shape, a tiny sphere suspended in the liquid. Then, slowly, almost imperceptibly, the ink begins to spread. It swirls, stretches, and thins. Within seconds it disperses completely, blending into the water until it becomes impossible to tell where the ink ends and the water begins. Decoherence works in much the same way. Quantum states start off pure and crisp like the droplet, but the slightest contact with the surrounding world, a stray photon, a vibration, a breath of warmth, spreads these states out. They mix with the environment until the original delicate pattern is lost. This is why we don't see superposition in everyday objects. A particle the size of an atom can maintain its overlapping possibilities for a moment, isolated from the chaos around it. But something the size of a dust mote, or a grain of rice, or a chair, or a person, interacts constantly with the world. Every second, countless air molecules collide with our bodies. Light bounces off our skin. Heat flows between us and the room. Each interaction is like another ripple mixing the ink into the water, making it impossible for large-scale quantum superpositions to survive. You can picture decoherence as the universe's way of settling into a stable, story-like form. Without it, reality would shimmer with possibilities in every direction. Chairs might hover between being upright and toppled. Doors might be both open and closed. But decoherence keeps things calm. It ensures that the world we experience is solid, predictable, and safe to navigate. In a sense, decoherence is the gentle hand smoothing the wrinkles in the cosmic fabric, letting us live inside a coherent and familiar reality. One of the most soothing ways to imagine decoherence is to think of how quickly a dream fades upon waking. In the moment between sleep and awareness, the dream feels vivid, full, and utterly real. But as soon as your senses begin to pick up the room around you, the dim light, the quiet air, the weight of the blanket, the dream dissolves. It blends into the background, slipping away until only fragments remain. The waking world fills in the details, leaving no room for the dream to remain crisp. Decoherence works the same way, dissolving quantum dreamlike states when they touch the larger world. Scientists sometimes explain decoherence with symbols or mathematical statements, but the essence can be held in a simple image. Exposure erases delicacy. Imagine trying to keep a soap bubble intact in a room full of swirling wind. Each gust, no matter how small, shakes the bubble's fragile surface. If the wind becomes too strong, even if it is only the faintest breath, the bubble bursts. Quantum states are like these bubbles. They can float and shimmer only when conditions are still, when the surrounding world does not disturb them. But the everyday world is never still, and so the bubbles rarely last long enough for us to see them. Decoherence also explains why measurements in quantum physics seem to force a choice. When a particle in superposition interacts with a measuring device, which is a large, noisy, warm object, its delicate possibilities mix instantly with the environment. The state becomes spread out so widely that it no longer acts like a single quantum object with multiple possibilities. It becomes like ink diffused so completely that the original droplet is gone. There is no single moment where a decision is made. Instead, the universe gently guides the system into a stable outcome, simply because stability is easier in a world full of interactions. You might wonder what this means for the idea of parallel universes. If decoherence hides quantum possibilities, does it also hide the branching of many worlds? Some interpretations say yes, that each branch is like a thread drifting away into its own quiet corner of existence, unreachable from where we are. Decoherence, in this view, is the soft curtain drawn between these threads. It prevents them from interfering with one another. The branches continue, but like dreams fading into the edges of memory, we cannot step into them. They become separate stories, each unfolding in its own way. This does not have to be unsettling. In fact, it can be comforting. Decoherence ensures that the world feels steady. It allows you to sit on a chair without wondering which version of the chair you might land on. It lets you trust that your keys, your cup, your door, and the ground beneath your feet are all in stable, definite states. Decoherence may hide the shimmering quantum layers, but it creates the consistency that life depends on. There is a gentle beauty in this. It means the universe holds wonder in its depths while still offering calmness on its surface. Like a quiet lake that reflects the sky but hides schools of tiny fish moving beneath the still water, the universe gives us a familiar world to live in while keeping the delicate dance of its foundations tucked out of sight. If you imagine reality as a melody, the quantum world plays the soft, intricate harmonies beneath the main tune. Decoherence is what blends those harmonies into the background so the melody can sing clearly. Without it, the music might be too complex, too intertwined, too shimmering for us to follow. Instead, we get a gentle, coherent song, one that is stable enough for consciousness to flourish. As you let these ideas settle, you may start to sense a softness in the structure of reality. Beneath every solid object, beneath every settled moment, lies a quieter world full of possibilities. Decoherence is not the end of those possibilities. It is simply the way they remain hidden, allowing our everyday experience to unfold with clarity and comfort. And in the spaces where decoherence grows thin, in the far reaches of space, or in the small territories of isolated atoms, the universe still whispers its quantum secrets, waiting for us to listen. If superposition is the universe holding several possibilities at once, and decoherence is the gentle dissolving that hides those overlapping possibilities from our everyday experience, then the many worlds interpretation is one possible way of understanding what happens to those possibilities when they no longer remain together. It is a theory that treats every potential outcome not as something the universe discards, but as something the universe allows to unfold in its own quiet corner. Instead of choosing one thread of reality and cutting away the others, the many worlds view says the universe might let all threads continue, each one becoming its own story. To imagine this softly, picture a great tree standing, alone in a peaceful field at dusk. At the base of the trunk, the tree is singular and solid. This trunk is like the shared quantum state before any interaction. But as you look upward, branches begin to split, first into 2, then 4, then more, until the canopy becomes an intricate web stretching across the twilight sky. Each branch is distinct, yet all belong to the same living structure. This is how many worlds imagines reality. Every time a quantum event presents multiple possible outcomes, the universe does not pick just one. It grows a new branch for each. In this view, when a particle can be in 2 places, the universe doesn't choose. It allows one branch where the particle lands here, and another where the particle lands there. When a spinning electron has 2 possible orientations, the universe does not force a decision. One branch carries the outcome this way, while another carries the outcome that way. No formulas are needed to hold the idea. It is simply the universe exploring all of its possibilities, gently and without hurry. This raises an intriguing question. What about choices made by larger beings, like you? In the many worlds interpretation, every action that depends on a quantum event, no matter how small, causes branches to form. Since our bodies, senses and brains are built upon quantum processes, some versions of this idea suggest that our own lives might follow branching paths as well. One version of you takes a walk, another stays inside. One version sends a message, another hesitates. Not as dramatic forks in destiny, but as quiet ripples arising from the deep quantum foundation beneath your decisions. This does not mean that your consciousness leaps between branches like stepping stones. Instead, each branch holds its own continuous version of awareness. Imagine lanterns glowing across a quiet valley, each lantern representing a version of you living out a slightly different path. You cannot see the other lanterns, and they cannot see you. But together, they paint a gentle landscape of possibility. Some people find this idea unsettling, but it can also be comforting. If every possibility finds its home, it means no potential is truly lost. The universe does not destroy paths, it simply allows them to unfold separately. In this way, reality becomes not a narrow corridor, but a wide, branching orchard, filled with stories you've lived and stories you might have lived, each one drifting away softly into its own corner of existence. The many-worlds interpretation was proposed as a way of making sense of quantum mechanics without invoking sudden collapses or mysterious choices. Instead of saying the universe decides when to settle into one outcome, it suggests the universe simply expands to accommodate all outcomes. This expansion is not physical in the sense of galaxies growing or space stretching. It is more like a conceptual blooming, a quiet unfolding of all potential paths. From a scientific point of view, this interpretation avoids the need for special rules or hidden mechanisms. Everything follows the same smooth laws. But from a human perspective, it opens doors into a broader understanding of reality. One where uncertainty is not erased but embraced. One where parallel histories coexist even if we cannot access them. If you hold this idea in your mind without trying to grasp every detail, it becomes almost poetic. Reality is not a single line, but a soft collection of lines, like strands of river water splitting around rocks and trees, only to drift onward in parallel. Each strand remains part of the same flowing whole, yet each finds its own course. You might wonder why we cannot see or feel these other branches. Decoherence offers the answer. Once branches separate, their delicate quantum states no longer overlap. They spread out like ink dissolving in different containers of water. The processes that smooth our everyday world into stable forms also create boundaries that keep branches from interacting. Even though they all arise from the same original state, once separated, they drift out of reach, unable to communicate or interfere with one another. This separation is why the many worlds idea doesn't disrupt our daily lives. You will always experience a single, coherent path, because that is how consciousness unfolds, steadily, from one moment to the next. The other branches are not places you can visit. They are simply different versions of the same cosmic story being told in parallel. Whether the many worlds interpretation is literally true remains an open question. Some physicists support it because it keeps the laws of quantum mechanics simple and unbroken. Others hesitate because these additional branches, although elegant in theory, are difficult to test or observe. But as a way of thinking about possibility, it holds a kind of quiet beauty. It treats the universe not as a narrow hallway, but as a vast branching forest where every leaf is a story. As you let this idea settle, imagine again the quiet field at dusk, with a great tree rising above you. Its branches stretch outward in all directions, dividing and redividing, each one holding a path the universe has allowed to unfold. You stand beneath this tree, rooted in one branch of reality, following the line of experience that belongs to you, but around you, unseen, silent, unreachable, countless other branches spread into the evening light, reminders that the universe is far richer than the single story you can observe. The many worlds interpretation doesn't ask you to believe in parallel universes. It only invites you to notice that possibility lies at the heart of existence, and that even if you walk only one path, the universe may be softly exploring all of them. When we look at the night sky, the universe feels calm and unchanging, as though it has always been the way it is now. Stars scattered like glowing, seeds, galaxies drifting in a slow cosmic dance, the darkness stretching endlessly between them. But in its earliest moments, the universe was nothing like this quiet scene. It was a newborn cosmos filled with unimaginable heat, brightness, and pressure. A place where everything that would one day form stars, planets, oceans, and even the thoughts in your mind was still compressed into something smaller than a grain of dust. Out of this tiny beginning came one of the most extraordinary events in the history of existence. Cosmic inflation, the universe's first great breath. To understand inflation without symbols or equations, imagine holding a small balloon between your hands. At first, the balloon is soft and flat. Then, with a single gentle breath, it expands rapidly, stretching out faster than your eyes can follow. This is similar to what scientists believe happened to the universe in the first fraction of a moment after its birth. Space itself didn't grow slowly or steadily. It didn't even expand the way we see galaxies drifting apart today. Instead, it surged outward in an almost unimaginable burst, growing from something tiny to something vast before even a heartbeat could pass. This rapid expansion smoothed everything out. Before inflation, the universe might have been uneven, like dough that hasn't been kneaded fully, with lumps and bumps throughout. But inflation stretched those irregularities wide and thin, leaving behind a universe that was nearly uniform everywhere. It's a bit like shining a bright light on a wrinkled sheet and watching those wrinkles disappear as the cloth is pulled taut. The sheet becomes smooth, flat, and ready for new patterns to take shape on its surface. Even though inflation happened far beyond the reach of memory or experience, we can still see its fingerprints today. One of the clearest clues comes from the faint glow that fills the sky, the ancient light left over from the early universe, often described as the cosmic background. This light is like a whisper from a time when everything was still hot and glowing. When scientists look closely at it, they find tiny variations, small ripples that resemble grains of dust caught in early morning sunlight. These ripples are the stretched out remnants of quantum fluctuations, little tremors in the fabric of reality that inflation expanded to cosmic scales. In the same way that a ripple in a pond spreads outward to cover a larger area, these early fluctuations became the seeds of galaxies and clusters we see today. It might feel strange to imagine quantum fluctuations, tiny shifts far smaller than an atom, becoming entire galaxies. But inflation works like a magnifying glass held up to the early universe. It took the smallest hints of structure and blew them up into the patterns we observe across billions of light years. No symbols or technical expressions are needed to describe this. It is simply the idea that the universe grew so quickly that even its tiniest ripples became enormous waves. You can picture inflation as a kind of cosmic stretching. Imagine painting a small dot on a balloon. At first, the dot covers hardly any space. But as you inflate the balloon, the dot stretches, grows, and becomes large enough to see clearly. Inflating the balloon doesn't create new paint. It simply spreads out what was already there. Inflation did the same with the early universe, stretching its tiny imperfections until they became the grand structures of galaxies and cosmic webs. Inflation also helps answer a quiet mystery. Why is the universe so vast and so smooth in every direction? When we look out into space, no matter which way we turn, the universe appears remarkably similar. Galaxies are scattered evenly. The temperature of the ancient light is almost identical everywhere, with only the faintest variations. Without inflation, it's difficult to explain how regions of the universe that are far apart could have ended up so similar, especially since light has not had time to travel between them. But inflation solves this gently. It suggests that before the rapid expansion, these regions were very close together, sharing the same temperature and properties. The universe expanded so quickly afterward that these once nearby regions drifted far apart, carrying with them identical memories of those early moments. Perhaps the most intriguing idea connected to inflation is that it may not have been a one-time event. Some theories suggest that inflation might be eternal, not in the sense that the same region keeps expanding forever, but in the sense that new regions begin their own expansion endlessly. Imagine a pot of gently simmering soup. Every now and then, a pocket of air forms a bubble that rises to the surface. In some models of inflation, space behaves similarly. One region of space settles down and becomes a universe like ours, while other regions continue expanding, forming new bubbles of space-time that may become universes with their own histories, their own laws, and their own shapes. These bubble universes are not placed inside ours, like rooms in a house. Instead, they are separate pockets of reality, each developing independently. From the inside, each bubble feels complete and enormous. From the outside, if an outside even makes sense, the bubbles are simply different regions of a larger, ever-expanding field of space. No hard numbers or complex models are necessary to hold this idea. It is simply the universe blossoming in countless directions, like a field of dandelions scattering their seeds in the wind. As you picture inflation, imagine the universe not as a static place, but as something alive in its earliest moments, breathing outwards, smoothing itself, taking shape, and quietly preparing the stage for everything that would come after. It is the gentle beginning from which galaxies, stars, and life itself eventually emerged, and in the softness of that beginning, we find some of the earliest hints that our universe may not be the only one. Inflation suggests that the cosmos might be far larger than the visible stars, filled with regions we cannot access but which share a common ancestry. Let this thought settle around you like a warm blanket. The universe you see tonight, with its calm, scattered stars and peaceful darkness, is the result of a single breath taken long ago. A breath so vast and so sudden that it set the stage for everything we know. And though the details of that breath remain partly hidden, we can still feel its echo across the sky, carried in the faint glow of ancient light and in the quiet patterns of galaxies drifting through space. In the last quiet steps of our journey, we imagined inflation as the universe's first deep breath, a sudden and astonishing expansion that smoothed out chaos and prepared the stage for stars, galaxies, and eventually for you lying here listening tonight. But for some physicists, inflation does not simply belong to the past, sealed away in the first moments after the beginning. In some models, it continues, quietly and endlessly, in regions we can never see. This is the idea of eternal inflation, a universe where new universes keep blooming again and again in a calm but unending process. To hold this idea in your mind, picture a large pot of water gently simmering on a stove. If you watch it closely, you notice something soothing and repetitive. Tiny bubbles begin to form at the bottom, grow, and then rise to the surface, popping softly before new ones appear in their place. The water itself is continuous, but within it individual bubbles are born, grow and vanish in an ongoing rhythm. Eternal inflation imagines space behaving in a somewhat similar way. There is a larger background region where space continues to expand incredibly fast, like the water still simmering. Within that inflating background, bubbles sometimes form, and each bubble can grow into a universe all its own. From inside one of these bubbles, everything looks complete. Space stretches in all directions, galaxies can form, time flows forward. There is no obvious hint that your entire universe began as a tiny, newly formed bubble in a much larger, inflating sea. To you, this bubble is simply the universe. The stars above, the vast darkness between them, the delicate swirl of galaxies, they all exist within your bubble's boundary. But eternal inflation suggests that beyond that boundary, beyond anything we could ever observe, other bubbles may be forming, each becoming its own universe with its own history. These bubble universes might not all be like ours. In some, the values that control gravity, the masses of particles or the way space expands could be slightly different. In others, these differences might be so dramatic that their universes would be unrecognizable, with no stars or no atoms or structures beyond anything we could imagine. You can think of each bubble as a new attempt at a cosmic story, each one shaped by a different set of starting notes played on the grand instrument of physics. If you let your imagination drift, you might picture a dark, peaceful cosmic ocean where bubbles of light appear here and there, each one growing into a separate universe. From inside any one bubble, the others are invisible, too far and too disconnected to ever be reached. There is no way to sail from one universe to another, no bridge of stars connecting their skies. Each bubble is a private room in a mansion so large that its other rooms are forever out of sight. This image introduces a second kind of multiverse. The first kind, from the quantum world, arises when possibilities branch into different paths, like a tree. This second kind, from eternal inflation, arises when space itself keeps blooming with new universes, like bubbles in a simmering pot. The two ideas are different, yet they both whisper the same message. What we call the universe might be just one piece of a much larger, quieter tapestry. You might wonder if this is only a poetic picture, or whether it comes from something solid in the mathematics of cosmology. Scientists did not invent eternal inflation simply because it is imaginative. It emerged naturally when they studied what happens if the conditions that gave rise to inflation persist in some regions of space. In those regions, inflation never ends. Instead of stopping everywhere at once, it stops only in scattered patches, each patch becoming a bubble universe. Meanwhile, the space between these patches continues to inflate faster than the bubbles can fill it, ensuring that new regions for new bubbles always exist. This leads to a gently paradoxical situation. While inflation ends locally within each bubble, globally it never stops. Somewhere, at some unreachable distance, space is always stretching, and new universes are always beginning. Time, in this grand picture, is not just the story of one universe, but of countless universes unfolding at their own pace. Even though we cannot reach these other bubbles, eternal inflation offers a way to think about some of the mysteries we see in our own universe. For example, it may help explain why the conditions here seem so delicately tuned for stars, chemistry, and life. If countless bubble universes exist, each with different properties, then it is not surprising that at least some of them, including ours, would have just the right balance for complex structures to form. We find ourselves in one of the rare bubbles where life is possible, not because it was guaranteed, but because only in such bubbles can beings like us arise to ask these questions. As you rest and listen, it is not necessary to decide whether eternal inflation is true. What matters is the gentle shift in perspective it offers. Instead of seeing the universe as a single, isolated object, you can imagine it as one bloom in a vast cosmic garden, surrounded by other blossoms you will never see, but which exist all the same. Each universe is a quiet experiment in what reality can be, each one carrying its own version of space, time, and possibility. There is a calmness in this view. It tells us that existence is abundant, not scarce, that the cosmos may be overflowing with worlds, even if we can only ever inhabit one. And while our universe feels enormous, and it is, eternal inflation places it within an even larger story, one in which new universes keep blooming like soft bubbles rising in a pot that never stops simmering. You, lying here under your own sky, belong to one of these bubbles. Your life, your memories, your quiet thoughts tonight are all part of this universe's unfolding story. And somewhere beyond all horizons, beyond all light and time, other stories may be beginning too, each carried within its own newly formed bubble of space. If you step back mentally and look at the universe not as a collection of galaxies and stars, but as a set of conditions that must be just right for anything meaningful to exist, a gentle and almost mysterious picture begins to form. Everything you see, your breath, the warmth of your skin, the light in the room, the stars overhead, depends on a delicate balance of cosmic ingredients. These ingredients are not objects but values. The strength of gravity, the masses of the tiniest particles, the way space stretches and expands, the structure of forces holding matter together. And what makes this picture truly astonishing is how precisely those values must be arranged for the universe to work the way it does. Physicists sometimes call this fine-tuning, but you do not need equations or symbols to understand it. Imagine instead a wooden board lined with small knobs, each one controlling a different aspect of the universe. One knob adjusts how tightly gravity pulls, another sets how strongly particles stick together inside atoms, another determines how quickly space expands, still another shapes how starlight forms, how planets emerge, and whether chemistry can unfold in all its richness. If you picture yourself standing before this board, you notice something surprising and strangely calming. The knobs cannot be set just anywhere. They each need to sit within narrow ranges, not exact single points, but slim, gentle intervals. Move the gravity knob slightly higher, and stars collapse too quickly into dense black spheres. Move it slightly lower, and stars never ignite at all, leaving the universe dark, cold, and empty. Adjust the particle mass knob too far in either direction, and atoms cannot hold together. They fall apart before they can form anything more complex than a fleeting spark of matter. These are not dramatic, razor-thin restrictions whispered through equations. They are simply quiet boundaries that shape whether a universe can become interesting, structured, and alive. The numbers themselves aren't important to recite. What matters is the image. A board with delicate settings, each contributing to a cosmic harmony that allows stars to glow, planets to orbit, oceans to form, and minds to wonder about all of this in the first place. The more scientists examined these settings, the more peculiar the picture became. It was not just one knob that needed to be right, it was many. Gravity had to be balanced with the strength of the forces that bind atomic nuclei. The masses of particles had to sit in comfortable proportions. Even the rate at which the universe expands, the gentle acceleration that stretches galaxies apart, had to fall within a small, calm range. If it stretched too quickly, matter would thin out before stars could form. If it stretched too slowly, the universe might collapse back in on itself before life had a chance to arise. All of this suggests a universe that is strangely hospitable, almost improbably so, unless there is some deeper explanation behind it. That explanation does not need to be mystical or dramatic. It may be as gentle as this. Perhaps our universe is one of many, each with slightly different settings on their cosmic boards. In that case, it is not surprising that at least one universe has the right balance for stars and life. You only find yourself inside a universe where life is possible, because only in such a universe can an observer exist to look around and ask questions. This is where scientific thought takes a subtle but captivating turn. Instead of imagining a single universe that must explain its own perfect conditions, some physicists consider the possibility that there are countless universes, each with its own arrangement of settings. In some universes, the gravity knob might sit too high. In others, particle masses might prevent complex chemistry from forming. In many, the expansion of space might rush outward too quickly or fall inward too fast. Those universes, if they exist, would remain silent and dark. But among all these possibilities, a few might have just the right arrangement. And in one of those, perhaps ours, the quiet balance permits stars to burn steadily, planets to stabilize, oceans to ripple, and life to bloom. To make this idea easier to hold, you can imagine a vast music room filled with countless pianos. Each piano is tuned slightly differently, some too sharp, some too flat, some harmonious in strange and unexpected ways. Only a few pianos are tuned in such a way that they can play melodies that feel warm and familiar. Our universe may be one of those few, a cosmic instrument tuned just right for the music of existence. Another comforting analogy is to imagine seeds scattered across a wide field. Many seeds fall in places where soil is too thin, sunlight too scarce, or water too limited. They remain dormant. But some seeds land in just the right patch of ground and bloom. In this gentle view, universes are like seeds. Most may remain barren, but here, in this one, life found fertile ground. The fine-tuning of the universe does not prove the existence of other universes. It simply raises a question. Is this universe uniquely balanced because it was meant to be, or is it balanced because it is one blossom among countless others, and only blossoms like this can host beings who wonder about their origins? Physicists remain cautious. Some argue that the delicate balance is evidence of underlying principles we have yet to discover. Others suggest that fine-tuning makes sense only if we imagine a multiverse, a large collection of universes, each with different settings, making ours simply one calm island within a larger cosmic archipelago. What is important for us, listening softly tonight, is not which explanation is correct, but the wonder that fine-tuning evokes. It encourages us to see the universe not as an accident or inevitability, but as a quiet, intricate balance of conditions. This balance holds everything you know: the warmth of your body, the chemistry of your brain, the glow of stars, the patterns of galaxies, and the deep silence between them. If you let this idea rest gently in your mind, fine-tuning becomes less a scientific puzzle and more a soft recognition of how fragile and precious existence really is. It is the realization that the universe is not arbitrary but balanced like a lantern flame shielded from the wind, bright enough to warm space, delicate enough to remain steady, and mysterious enough to fill your thoughts with awe. And perhaps, as we move forward into the idea of multiple possible universes, this fine-tuned balance becomes one of our quiet clues. If our universe is shaped by settings so precise, then maybe these settings are not singular at all, but one arrangement among countless arrangements waiting in the wings, each telling a different story about what reality can be. If fine-tuning invites us to imagine the universe as a board of delicate knobs set within narrow ranges, then the string landscape takes this picture and expands it into something far more sweeping, an almost boundless gallery of possible worlds. It comes from a branch of theoretical physics known as string theory, but you do not need to know the technical language behind it. What matters for tonight is the gentle image it paints, that the universe might not have been forced into just one configuration. Instead, nature may allow an enormous variety of possible cosmic blueprints, each one giving rise to a different kind of universe. To hold this idea peacefully, imagine walking into a library so large that you cannot see its end. The shelves stretch far into the distance, disappearing into a soft haze. Each shelf is lined with books of all sizes and thicknesses, their spines glowing faintly in the dim light. Every book in this quiet library contains the blueprint for a universe, not just a description, but a complete set of physical laws, values, and structures. Open one book and you might find a universe much like ours, filled with galaxies, stars, and planets. Open another and you might discover a world where gravity is slightly stronger, where stars burn hotter, or where atoms behave in ways unfamiliar to us. Open yet another, and you might find a universe where the very idea of space is different, more dimensions, different kinds of particles, or no stable structures at all. According to some interpretations of string theory, the number of possible blueprints is astonishing. Not a handful, not hundreds, not even millions, but an unimaginably large collection. Some physicists estimate that the landscape of possible solutions could reach a number expressed as a 1 followed by about 500 zeros. You don't need to picture that number. Just think of it as a vast ocean of possibilities, so large that our own universe is like a single drop resting atop a wave. In this view, the laws of physics we observe, the strength of gravity, the nature of particles, the structure of space, are not uniquely fixed. They might instead be the settings chosen by our universe, just one choice among many. And this is where the connection to eternal inflation becomes beautifully natural. If inflation produces bubble universes, and if the string landscape provides a large set of possible cosmic blueprints, then each bubble might select one blueprint as it forms. Some bubbles might settle into patterns where stars shine brightly and chemistry unfolds richly. Others might settle into blueprints where matter never forms stable structures. Still others might host physical laws unlike anything we can currently imagine. Picture the library again. Eternal inflation is like a gentle breeze passing through the stacks, causing certain books to open themselves and bring their stories to life. Each opened book becomes a universe, its pages unfolding into space and time. The rest of the library remains quiet, filled with countless books that may never open, but each one still holds the potential to describe a universe. What makes the string landscape particularly intriguing is that it offers a way to think about why our universe appears so finely balanced. If there are a vast number of possible universes, each with different laws, then it is not surprising that some of them, perhaps only a tiny fraction, are hospitable to life. Our universe would simply be one of the rare ones where the conditions happen to fall within the gentle range needed for stars, planets, and beings like us to exist. This doesn't prove the landscape is real, of course, but it provides a calm and elegant framework for thinking about the fine-tuning puzzle. Another way to visualize the landscape is to imagine a massive field of wildflowers stretching over rolling hills. Each flower is a different color, each petal has its own pattern, and every bloom represents a possible universe. Some flowers are bright and vivid, full of complexity. Others are pale or sparse. Most will never be noticed or visited. But together they form a vast, breathtaking field of possibility. Our universe is simply one flower among these millions, blooming quietly in a corner of the field. The landscape also raises a gentle and philosophical question. What does it mean for something to be real? If these possible universes are described by the mathematics of string theory, does that make them actual physical worlds? Or are they only potential worlds, existing as ideas within the larger structure of reality? There is no consensus. Some physicists believe the landscape describes literal universes, each one as real as ours. Others think it represents possible patterns in the underlying laws, not distinct physical realms. Still others treat the landscape as a tool, a way of exploring the flexibility of nature's rules without claiming that each possibility must exist. No matter which view is correct, the string landscape invites us to broaden our imagination. Instead of assuming our universe is the only way reality could be, it encourages us to think of existence as something spacious, not a single house, but a sprawling city, not a single melody, but an entire symphony. This spaciousness brings comfort. It means the universe does not need to be precisely one way by necessity. It could simply be one expression among many, chosen by the unfolding of cosmic history. As we reflect on the landscape, it becomes easier to see how the idea of parallel universes grew from scientific curiosity rather than fantasy. If nature allows so many possible configurations, and if the early universe produced countless bubbles, then the idea that other universes may exist becomes a natural extension of the physics we study, not proven, but gently hinted, like an echo heard from just beyond the edge of a quiet forest. And while we cannot open the books in this library ourselves, we can feel their presence through the questions they inspire. Why are the laws of our universe so precisely balanced? Why do the constants of nature fall into ranges that allow stars and life? Why does the cosmos appear both vast and strangely delicate? The string landscape does not answer these questions with certainty, but it gives us a place to begin exploring them, without fear and without haste. As you let this idea settle, imagine yourself standing once more in the endless library. The air is still. The shelves stretch out into infinity. You hold one book in your hands, the blueprint of the universe you call home. For tonight, that single book is enough. But the knowledge that countless others may exist invites you to wonder, softly and without any need for conclusion, about the wider possibilities hidden in the quiet beyond. When you look up at the night sky, the darkness between the stars appears still and empty. But behind the darkness lies something ancient, a soft glow so faint that it took humanity thousands of years to notice it. This glow is called the cosmic background light, the leftover warmth from the earliest era of the universe. You can think of it as a kind of cosmic afterglow, the cooling embers of a fire that once filled all of space. Even though billions of years have passed, the universe has never become fully dark. It still carries this whisper of light, spread thinly across the sky. If you could float above Earth and observe this glow with special instruments, you would see not a uniform blanket but a pattern, a tapestry of tiny variations. Some spots are slightly warmer, some slightly cooler. These differences are incredibly subtle, far too small for human senses to detect, yet they are important. They are the seeds of galaxies, the fingerprints of the early cosmic landscape, imprinted long before stars were born. Scientists map these variations like cartographers mapping an ancient continent. And in doing so, they have found a few curious features, small blemishes, cold regions, and unusual alignments that do not fit perfectly with the simplest expectations. One of these is often described as a cold spot, a region of the sky that is a little cooler than theory predicts. Not dramatically cooler, just gently, like a patch of fabric that hasn't warmed in the sun as much as the rest. Some physicists suggest it might be nothing more than a statistical coincidence. Others wonder whether it could hint at something larger. Here is where imagination quietly steps in beside science. One idea suggests that this cold patch might be a bruise, not literally of course, but a kind of imprint left behind from a close brush with another universe. If two bubble universes formed during eternal inflation drifted near each other long ago, they might have pressed together for a brief moment before drifting apart. Such a soft collision could leave a slight distortion in the cosmic background of one universe. It would be a delicate signature, like a faint ripple spreading across still water. This idea is not proven. It rests on assumptions, interpretations, and models that cannot be confirmed directly. But it is gentle and evocative, and it shows how scientists use subtle patterns in ancient light to explore possibilities far beyond what telescopes can see. Another curiosity comes from the alignment of certain temperature patterns in the cosmic background. Instead of appearing random, as one might expect from early chaos, a few patterns seem to line up in unusual ways, a bit like the grains in a piece of wood running in an unexpected direction. These alignments could simply be chance, or they could hint at features of space we haven't yet understood. Perhaps something in the early universe nudged these patterns into place. Perhaps something from beyond our observable universe left a quiet trace. Even if these anomalies turn out to be coincidences, they serve an important purpose. They remind us that the universe is not a perfect sphere of predictability. It is more like a hand-woven blanket, mostly smooth, but with occasional irregularities where the fibers twist or tighten unexpectedly. Each irregularity invites a question. Each question invites a new way of thinking. One of the remarkable things about the cosmic background is its age. This light has been travelling since the universe was less than 400,000 years old, an age so early that atoms had only just begun to settle into stable forms. When we observe this ancient glow, we are looking back across nearly the entire history of existence. No telescope, no matter how powerful, can look further in electromagnetic light. The cosmic background is the universe's oldest visible memory, and just like human memories, it carries both clarity and uncertainty. The overall image is clear, a universe that began hot, dense, and uniform, then cooled and expanded. But the details, these tiny patterns, cold spots, alignments, and asymmetries, remain open to interpretation. They could be the result of natural randomness. They could be artifacts of the models we use, or they could whisper faintly of something beyond, like the muffled sound of footsteps in a hallway you cannot see. It is important to remember that scientists do not claim these hints as evidence of parallel universes. The cold spot does not prove a multiverse. The unusual alignments do not point definitively to cosmic collisions. These features simply stir curiosity. They remind us that the universe has room for mystery and that our understanding is still unfolding gently. Perhaps the most calming way to think about the cosmic background is to imagine it as the universe's first lullaby, a soft hum that carries the memory of everything that came before. Its patterns are not messages but natural textures. Its faint glow is not a signal, but a reminder that we are connected to a story that began long before life on Earth opened its eyes. The anomalies within this glow are simply the natural quirks of a vast cosmic child learning to breathe. As you let the image of this ancient light settle into your thoughts, imagine standing in a dark field at night, the air cool against your skin. Above you, stars shine like tiny lanterns, each one a distant reminder of the universe's early moments. But behind those stars, too faint for your eyes to see, is the cosmic background, the soft glow of a universe that remembers its own beginning. It is in that quiet glow that scientists search for clues, not because they expect definitive answers, but because they are drawn to the possibility that our universe may carry faint echoes of something larger. Whether those echoes point to other universes or simply to deeper layers within our own, they remind us that existence is bigger, gentler, and more intricate than we can see at first glance. And so, with a calm curiosity, we follow these faint patterns in the early light, knowing that even if they never reveal other worlds, they have already revealed something beautiful, that the universe in all its complexity still carries softness at its core. When we picture a black hole, many of us imagine a swirling dark vortex, a place where gravity becomes so intense that even light cannot escape. It is a haunting image, almost mythic, as if black holes are the universe's hidden wells, deep, dark, and unknowable. And yet, despite their intimidating reputation, black holes are also among the most peaceful and intriguing objects in the cosmos. They do not roar or crackle or tear things apart violently the way movies often show. Instead, they sit in quiet corners of space, bending light gently around themselves, humming with subtle gravitational whispers. Tonight, we explore a soft and speculative idea. What if black holes are more than just cosmic endpoints? What if, in some interpretations, they act as gateways, not in the literal science fiction sense of stepping through to a new land, but in a deeper, more mathematical or structural way? What if the strange geometry inside a black hole hints at other universes, or even plays a role in creating them? To ease into this thought, imagine a calm river flowing across a smooth landscape. In most places, the water glides gently, reflecting the sky. But every now and then, the water spirals downward into a whirlpool, a place where the current bends sharply and flows inward instead of outward. A whirlpool is not a portal to another ocean, but it changes the water's journey entirely. A leaf floating on the surface might glide peacefully, then suddenly get pulled into a downward spiral that leads somewhere unseen. A black hole is something like that. Not a violent monster, but a region where the normal flow of space turns inward, guiding everything toward its center. Scientists describe the boundary of a black hole as its event horizon, but instead of imagining it as a wall, picture it as a line beyond which all pathways point inward. If you step past this invisible line, even the path that would normally let light escape curves inward like the flow of a whirlpool. No hard symbols are needed, just imagine a gentle curve where space itself bends like a river meeting a deep hollow in the ground. But what happens deep inside past the horizon? We do not know. The laws we use to describe gravity begin to break down under such extreme conditions. Inside a black hole, the density becomes so enormous that our usual equations lose their clarity. Some researchers propose that, instead of collapsing into a true point of infinite density, the interior structure might connect to another region of space entirely, something like another bubble, another pocket, another universe. This is just one possibility, and it remains deeply theoretical. But it carries a quiet beauty. Imagine space folding gently like soft fabric gathered by an unseen hand. In one fold, our universe forms. In another fold, a black hole forms. And somewhere deeper within that fold, another patch of space could open. In this gentle picture, black holes are not merely the end of matter and light. They might also be doorways, not ones we can step through, but ones through which reality itself may transition into something new. Another interpretation suggests that the intense conditions inside a black hole could trigger something similar to a new beginning. The universe we live in began with a burst of expansion, not a violent explosion, but a rapid unfolding of space from a highly compressed state. Some scientists propose that the birth of a new universe might occur when a region collapses so densely that it triggers this kind of unfolding. In this view, every black hole might hold a seed, a quiet chamber where conditions mirror the birth of a new universe, hidden from ours by the event horizon's gentle veil. This does not mean that stars falling into a black hole become planets in another universe, or that memories and objects cross between realms. Instead, the idea is more like this. The collapse of matter here might lead to the birth of entirely new space elsewhere. A mother universe giving rise to children universes, each one expanding independently, unaware of the others. Like a vast forest where each tree drops seeds that drift far away and grow into new trees, unseen by their parent trunk. If you find this idea captivating, you are not alone. Some physicists explore it to understand how universes might be related. Others consider it because black holes seem to hold mysteries in their structures that hint at more than simple destruction. And although these ideas are speculative, they remain gentle and thought-provoking. They ask questions without demanding answers. One such question comes from something called the information problem. When something falls into a black hole, what happens to the information that describes it? Does it vanish forever? Or does it become part of the black hole's surface, perhaps to be released slowly over unimaginable stretches of time as the black hole evaporates in a soft glow known as Hawking radiation? There is no single consensus, but some interpretations suggest that the information might unfold into a new region of space, just as a seed holds the pattern for an entire tree. Again, these are not firm conclusions, they are invitations, quiet paths the mind can follow while resting, like wandering through a peaceful garden where each turn reveals a new possibility. What matters most for tonight is the feeling these ideas bring. Black holes, instead of being terrifying dead ends, become gentle symbols of transition. Places where the universe changes shape. Places where the known gives way to the unknown in the softest and most mysterious way. If you imagine a black hole as a whirlpool leading to another hidden pool, not because we know this to be true, but because the metaphor helps you settle into the mystery, the cosmos becomes a little more welcoming. The darkness becomes a place of wonder rather than fear. And perhaps that is the quiet gift of this idea, that the universe we see is not rigid or finished, but alive and full of hidden pathways, that even the darkest places hold the potential for new beginnings, and that in the stillness of space, where black holes drift silently like ancient wells, there may be more happening than our senses can ever know. As you breathe gently and let your thoughts drift, imagine floating along a calm river. The surface is smooth, the sky reflects in clear lines, and somewhere along this river a whirlpool forms, not a trap, but a passage. You do not need to know where it leads. It is enough to know that the universe, in all its quiet vastness, holds mysteries deep within its folds, waiting patiently for minds bold enough and gentle enough to wonder about them. In our journey so far, we have wandered through the quiet strangeness of quantum possibilities, drifted across the blooming fields of bubble universes, and stepped gently into the soft geometry of black holes. each idea has offered a glimpse of something larger, hints that reality may stretch beyond the single universe we can see. And yet, for all the wonder these concepts inspire, science has not woven them into a single complete tapestry. Instead, we find ourselves in a tender space between what we know and what we can only imagine. This session is devoted to that space, the frontier where science pauses, takes a breath, and allows imagination to lean forward. To understand this frontier, picture a long shoreline at dusk. The land behind you is solid. Established theories, well-tested models, and observations confirmed countless times. This is the part of physics where certainty lives, the stable ground of experiments, equations, and careful measurements. But as you walk toward the edge of the shore, you feel the sand softening beneath your feet. This is where the waves touch the land, a place shaped by movement, possibility, and change. The waves themselves represent our questions, always reaching, always retreating, always carrying something new to the boundary of what we know. Let us first gather the gentle waves that have brought us here. One wave comes from entanglement, the quiet connection between particles that remain linked no matter how far they drift apart. Entanglement reveals a universe where relationships matter deeply, where distant places share information in ways that challenge our intuition. While entanglement itself does not prove the existence of parallel universes, it reminds us that the universe does not always respect the borders our senses expect. Another wave comes from the early universe and its patterns, the faint ripples in the cosmic background, the slight cold, patches, the unusual alignments that make scientists pause. These features may be natural quirks of the early cosmos, or they may be subtle fingerprints of interactions with something beyond our universe. They do not shout answers, they whisper possibilities. A third wave comes from the fine-tuning of our universe's settings, the delicate balance of forces, masses, and cosmic rhythms that allow stars and life to exist is intriguing. You can visualize these conditions as quiet knobs on the board of the cosmos, each set within narrow ranges. Why these values? Why this combination and not another? Some scientists suggest that if there are many universes, each with different settings, then it is not surprising that a few of them, including ours, allow for life. But this idea is not proof. It is a way of making sense of an otherwise delicate puzzle. A fourth wave comes from the string landscape, the vast library of possible blueprints for universes. Whether that library is literal or metaphorical remains an open question. Some physicists see it as a representation of different ways the universe might have unfolded. Others see it as a deeper structure waiting to be understood. Either way, it expands our imagination. It invites us to picture reality not as a single book, but as a shelf among many. And finally, one more wave comes from the black holes that sit quietly across the cosmos. The deep gravitational wells, their gentle warping of space-time, and the lingering mystery of what happens within them all hint at something beyond the horizon. Some models suggest that the collapse of matter inside a black hole could trigger the birth of a new universe. Others propose that black holes might be pathways to other regions of space-time. None of this is certain, and yet the idea feels like a soft reflection of nature's creativity. These waves meet at the same shoreline, where certainty fades into wonder. At this boundary, science becomes something more tender. Instead of demanding answers, it begins to ask gentle questions. What if the quantum branches of many worlds are not just mathematical conveniences, but actual threads of reality? What if eternal inflation has filled the cosmos with bubble universes, each born from the same cosmic ingredients but mixed into different recipes? What if the string landscape truly holds an enormous number of cosmic possibilities, each one waiting for the right conditions to unfold? What if black holes are not endpoints, but transitions? Places where one universe gives rise to another, Science cannot yet answer these questions, and importantly, it does not need to. What matters is that each question opens a doorway into a wider and more spacious understanding of existence. There is a gentle humility in acknowledging what we do not know. When scientists map the cosmic background, they do their best to interpret the faint ripples in ancient light. When they examine black holes, they rely on models that break in extreme conditions. When they explore the quantum world, they navigate a realm where our intuitions simply do not apply. In each case, they are like travelers exploring a dimly lit cave, one where each step forward is careful, patient, and filled with respect for the unknown. And this humility is not a weakness, it is a strength. It keeps science grounded while allowing imagination to flourish. It reminds us that the universe does not reveal all its secrets at once, but instead invites us to approach gently, as one might approach a shy animal in a quiet forest. Standing at the shoreline between knowledge and wonder, you can begin to see that the mystery itself is beautiful. Not because it promises answers, but because it allows you to feel the vastness of existence. A vastness not just in physical distance, but in possibility. A vastness that echoes both within and beyond the universe you call home. As you breathe softly and let your thoughts drift, imagine walking along that shoreline. The waves touch your feet, each one carrying a question, a hint, a possibility. The land behind you is firm, the sea before you is open, and somewhere in the gentle rhythm between them lies the true spirit of discovery. Not in the certainty of what we already know, but in the quiet willingness to explore what we do not. When you lie quietly in the dark, there is a gentle truth you can feel without needing to think about it. Your awareness moves in a single continuous line. One moment leads into the next. You remember what happened earlier in the day, you anticipate what might happen tomorrow, and everything between those 2 points feels like a single story you inhabit. But if the quantum world truly allows many possibilities to unfold, if the universe branches softly like a great tree spreading its limbs through time, then why does your consciousness experience only one of those branches? This question can feel deep, even unsettling, but approached softly, it becomes a calm reflection on what it means to be aware. Imagine your mind as a lantern moving through a vast forest at night. The lantern casts a circle of light around your body, warm, steady, and finite. Beyond that circle, the forest stretches in all directions, full of paths that split and wind and rejoin. But no matter how large the forest is, the lantern illuminates only one trail at a time. You cannot see the paths to your left or right unless you turn toward them. And even then, you cannot walk all paths at once. Your consciousness is like that lantern. It lights up one line of experience, one flow of moments, even if other possibilities exist quietly beyond the glow. If the many worlds interpretation is correct, if the universe branches whenever quantum possibilities diverge, then countless versions of events might unfold in parallel. Yet your awareness moves through only one of those threads, not because the others are erased, but because consciousness itself seems to favour coherence. It follows a single narrative, a line of memory that gives shape to your identity. You can think of this as the mind's way of staying balanced. Imagine trying to listen to 20 songs at once. Each melody might be beautiful on its own, but together they would blur into noise. Awareness feels best when it can follow one melody clearly. And so, in a universe filled with possibilities, your mind focuses on the thread it occupies, the one where your memories align, your thoughts make sense, and your emotions unfold in a familiar rhythm. This does not mean that the other branches are meaningless. They might exist as softly as dreams you never had, real in some sense, but not part of the story your consciousness follows. The mind does not reject those other possibilities, it simply does not travel down those roads. There is something comforting in this. It means the world you experience is not accidental. It is a coherent path woven from all the small choices and uncertainties that brought you to this moment. Your life is the story your mind can hold without fracturing, a gentle narrative through a vast sea of potential. You can picture this narrative as a thread being spun from a spindle. Each moment adds another inch of thread, smooth and continuous. The spindle represents the deeper quantum world, full of branching fibres that could form many threads, but the one you follow is the one the spindle winds into your memory. The rest of the fibres drift outward into the unknown, forming their own strands beyond your reach. This view also touches on the quiet question of free will. If many branches exist, if every small uncertainty produces new paths, then what does it mean to choose? In a soft, peaceful sense, it means that the branch you experience is shaped by your decisions. You cannot stop the universe from exploring multiple possibilities, just as you cannot stop a tree from growing new twigs. But you can still shape the story in the branch you inhabit. The choices you make influence the narrative your consciousness follows. You can think of this like writing in a journal. You may imagine many possible sentences before you write one, but the story becomes real only when you put a sentence onto the page. The sentences you did not write still existed in your mind, but they are not part of the story you chose to tell. In the same way, your life's branch becomes your story not because other possibilities vanished, but because this one is the path your awareness steps into. There is another deeper reflection hidden here. If consciousness follows a single branch, does that mean the you in other branches is truly you? Or is each branch a separate self, sharing a common origin but drifting into its own individuality? A gentle way to approach this is to remember how memories form. Think about a moment in your childhood, perhaps a day at a park, a schoolroom, a holiday gathering. The person you were then is connected to you now through memory and continuity. Yet you would not say you are identical to that earlier version of yourself. You have changed, grown, and become someone more complex. In this way, even within a single branch, you are not a single static being, but a flowing series of selves. The versions of you in other branches can be imagined the same way. They share a root with you, the trunk of the great tree, but each follows its own path. Each becomes a different expression of the same starting point. You do not need to feel responsible for those other selves, just as you do not feel responsible for all the possible things you might have done but never did. Your story belongs to you. Theirs belong to them. And if this sounds too abstract, return to the lantern in the forest. The forest may be vast, full of paths weaving into the darkness, but the lantern lights only the trail beneath your feet. The other paths remain quiet, untouched, and distant. You do not need to explore them all to appreciate the beauty of the forest. It is enough to walk the path your lantern illuminates, step by gentle step, in the soft glow of your own awareness. As you breathe calmly and settle deeper into the idea, you may find a quiet comfort. You do not need to be everywhere. You only need to be here. Your story, your memories, your quiet presence in this moment, this is the branch your consciousness knows. And within the vastness of the universe's possibilities, that single branch is a world unto itself, complete and meaningful, shaped by your choices and held together by the soft continuity of your mind. If you rest quietly for a moment and let your thoughts settle, you may notice a gentle feeling, the sense that your life is a single thread, woven from choices, memories, and small moments of chance. You wake up, you move through your day, you speak to people, you make decisions, and all of it forms a continuous story. But if the universe truly branches, softly and endlessly, then your story may not be the only one. For every moment shaped by uncertainty, there could be another version of you following a slightly different path. Not a shadow, not a ghost, not a duplicate waiting in the dark, but a fully formed self, as real and vivid in their branch as you are in yours. To feel this idea gently, imagine standing at the edge of a valley at night. The sky above is dark and quiet, with faint stars scattered like threads of light. Across the valley, far in the distance, you see lanterns glowing, dozens, then hundreds, each one flickering softly in the darkness. You cannot see who holds them, or what stories unfold beneath their glow. But each lantern represents a path of possibility. Each one is a life lived under slightly different choices, moments, and outcomes. And among those lanterns, some might belong to versions of you who walked a different trail when a decision branched into alternatives. These alternate selves are not better or worse. They're simply different. One version of you might have chosen a different career. Another might have moved to a new city. Another might have taken a chance you hesitated to take. Another might have said yes where you said no, or no where you said yes. Each small divergence, no matter how ordinary, becomes a unique story when followed far enough. Yet none of these versions are accessible to you. You cannot call out to them, cannot trade places, cannot compare their lives with yours. They exist beyond the soft boundary of decoherence, drifting through their own branches like lanterns carried by the wind. But the mystery deepens when you consider that alternate selves are not limited to personal choices. Some branches arise from differences so small you would never notice them. A single particle drifting slightly to the left instead of the right. A faint breeze forming a moment earlier. A photon arriving just one heartbeat sooner or later. These microscopic differences, far too small to sense, can gently shift the direction of an entire branch of reality. In those branches, your alternate selves might live lives shaped by events you never witnessed, yet events that feel just as natural and continuous to them as your memories feel to you. This can sound strange, but approached softly, it becomes a reflection on what it means to exist at all. You're not a solitary point in the cosmos. You're part of a vast river of possibility, shaped into one coherent current by the continuity of your awareness. The versions of you in other branches are simply currents flowing beside yours, unreachable, invisible, but equally real in their own gentle way. If you imagine these selves as mirrors, they are not mirrors you can look into. They do not reflect your face or confirm your choices. Instead, they are mirrors in the sense that they reveal something subtle about your identity, that you are not defined by a single path, but by the fact that you experience one path deeply. In the quiet of the night, this can feel comforting. It means your life is unique not because it is the only version, but because it is the version you inhabit, the version illuminated by the lantern of your consciousness. Another way to picture alternate selves is to imagine a tree in early spring. Each branch begins close to the trunk, sharing the same roots and the same beginnings. But as the branches stretch toward the sky, they separate, diverging into different directions. Up close, the differences are small. Further out, the edges become distinct. Yet all branches still belong to the same tree. In this sense, alternate selves are not strangers or distant copies. They are simply expressions of the same root, the potential contained in your existence at its beginning. It's tempting to wonder what these other selves would say if they could speak to you. Would they feel happier, sadder? Would they envy your choices or cherish their own? But these questions quietly dissolve once you remember that each self experiences their branch as naturally as you experience yours. None of them knows they are part of a larger tree. None feels incomplete. Each one holds a coherent identity, shaped not by infinite possibility, but by the single, continuous thread of their life. This idea can also help soften the weight of regret. All of us carry choices we sometimes revisit in our minds, moments when we wish we'd acted differently, spoken differently, understood differently. But if many branches exist, then somewhere in the vast forest of possibilities, a version of you did make those choices. They walk the path you sometimes wonder about. They live the life you imagine in passing. You do not need to experience every outcome for those possibilities to have meaning. This branch, the one your awareness follows, is the one meant for you, not because it is perfect, but because it is yours. And yet, alternate selves can also inspire empathy. If reality contains countless branches, each shaped by small events beyond any person's control, then every life becomes a delicate balance of chance and choice. We are shaped by circumstances we did not choose, the era we are born into, the family we grow up in, the opportunities available to us. In another branch, different circumstances would shape us differently. This realization can soften your judgment of both yourself and others. It reminds you that every life is a fragile path, one of many possible stories carried tenderly through time. As you breathe slowly and let the idea settle, imagine the Valley of Lanterns again. The air is still, the night is cool. Across the darkness, countless lights flicker, each one a universe's worth of choices, each one a version of you walking through a slightly different night. You cannot reach them, cannot merge with them, cannot know their stories, but you can acknowledge them as quiet reflections of what existence could have been. And then, with a soft sense of belonging, you return your attention to the lantern in your own hands, the one illuminating the path beneath your feet. This is your story. This is your night. This is the branch your consciousness inhabits, glowing gently as you walk through the mystery of the universe. Take a moment, wherever you are right now, to let the air settle around you. The room may be dim, perhaps only lit by a soft glow from a screen or a faint lamp in the corner. The world around you feels quiet, and in that quiet, the ideas we've travelled through begin to weave themselves into something whole. We've wandered through quantum possibilities, drifted past blooming universes forming like bubbles, stepped softly into the strange interiors of black holes, and reflected on the lantern-like glow of our own consciousness. And now, at the end of this long and gentle journey, it is time to gather these ideas into a single breath. The universe, for all its complexity, begins with something simple, the sense that reality is here in front of us, solid and familiar. You wake up, you move through your day, you look at the sky, and the world seems singular. One universe, one story, one life. But as we've seen, the deeper layers of physics suggest something far larger may be unfolding beneath that simplicity. Quantum physics offers whispers of branching paths, where possibilities do not always collapse into a single outcome but continue on their own quiet branches. In these deeper layers, the world feels less like a straight line, and more like the roots of a tree, spreading, dividing, and exploring every path it can. The formulas that physicists use to describe this often look sharp and abstract when written on a board, but when softened into imagery, they become something almost poetic. The universe holding multiple notes in a single chord before letting each one drift into its own melody. Cosmic inflation adds another layer to this spacious picture. Instead of imagining the universe as a single balloon that expanded once, we saw it as a simmering pot, where new universes may continue blooming endlessly like soft rising bubbles. Each bubble becomes a complete cosmos, with its own galaxies and its own story, sealed gently away from the others. These universes do not collide or communicate. They simply drift apart as space continues to swell between them. And even though we cannot see them, their existence allows us to imagine reality as a garden, filled with blossoms we'll never pick but which still add colour to the cosmic landscape. Fine-tuning invites yet another reflection, the recognition that our universe seems delicately arranged. The gravity that pulls your feet to the ground, the warmth of the sun that ripples across your skin, the atoms that make up your bones and your breath. All of these depend on values that sit inside narrow, gentle ranges. A little stronger here, a little weaker there, and stars might never burn, molecules might never bind, life might never explore. And so, whether or not there are countless other universes, the one we inhabit feels like something quietly precious, balanced like a flame sheltered from the wind. The string landscape stretches our imagination even further. It suggests a library of possible universes, each one a cosmic book containing its own physical laws. We may never open these books, but the idea that they exist at all carries a kind of calming humility. It reminds us that our universe, vast as it is, may be only one of many stories, one chapter in a collection too large for any single mind to read. And then there are the black holes, those quiet, dark wells in space that swallow light and time, yet may hide structures or transitions far more intricate than we can grasp. Some interpretations imagine that what collapses here might blossom elsewhere. Whether or not this is true, the image itself is soothing. Even the darkest places in the universe may hold the seeds of new beginnings. Beyond all the science, though, is the most intimate layer of this entire journey. You, the observer, the awareness, the lantern moving through a single branch of time. Your mind experiences one thread of reality, one story, one life. Even if countless possibilities unfold beyond your reach, the path your consciousness follows is enough. It is meaningful not because it is the only path, but because it is the one illuminated by your awareness. And in that awareness lies the true beauty of this exploration. You do not need to know whether parallel universes exist. You do not need certainty about the nature of time, or the number of dimensions, or whether black holes carry seeds of new worlds. The beauty lies in the possibility itself, the spaciousness of not knowing, the freedom to imagine gently, without fear or urgency. The universe does not demand answers. It invites curiosity. It invites wonder. It invites you to lie back, breathe softly, and let your thoughts drift like leaves on a slow river. If reality contains countless worlds, that is beautiful. If it contains only this one, that is beautiful too. In both cases, you are part of something vast and quiet, something unfolding with a grace that needs no conclusion. So as this journey comes to a close, imagine yourself holding a page from an endless book. On this page is everything you know, your memories, your hopes, your gentle questions about existence. Beyond this page lie countless others, filled with stories you will never read. But the page in your hand is warm. It belongs to you. And in the soft glow of your consciousness, it is enough. If your eyes are open, you may let them soften. If your mind is wandering, you may let it drift. If sleep is calling, you may follow it without hesitation. Whether you remain awake or drift into dreams, the universe will continue unfolding around you, quietly, patiently, beautifully, carrying its mysteries with the same gentle steadiness with which it carries the stars. Thank you for walking this path tonight, and for allowing the universe to unfold in your thoughts like a calm and endless horizon. Wherever you are, and whichever branch of reality you inhabit, may you feel the quiet reassurance that the unknown is not something to fear. It is a place of possibility, a space for wonder, and a reminder that existence is wider, softer, and more mysterious than any single story can contain.